You survived the last video, or maybe you didn't. I don't know. Maybe you're a puddle on the ground right now, and this is just the autoplay of YouTube. I don't know. But let's talk about where derivatives don't exist. There's no calculus. Well, there's no math. There's no calculations in this video, I think. Actually, I lied. Anyway, breaking trust at the start of the video. Let's go. Remember that the derivative of a function is the slope of the tangent line at that function. So if we ask ourselves, well, where does a derivative not exist? Really what we're asking ourselves is, when does a slope of a tangent line not exist? Well, when the tangent line is vertical. If you have a vertical tangent line, what's the slope? Right? If I have a line that looks like this, what's the slope of this line? It's undefined, right? So if you ever have a vertical tangent line, the derivative won't exist. Also, if there's a sharp corner or a cusp in the graph, the derivative won't exist. We'll show why later. And if the function's not continuous, the derivative won't exist. We won't see that until the next video where I look at some homework problems. But these are the three ways that a derivative can possibly not exist. Oh, nope, I do it right here. So example 15, the last example before we get into some homework problems. Where are the following functions not differentiable? So we got this red function over here. This is the cubed root function. Remember, you can write the cubed root function as a rational exponent, x raised to the power of 1 over 3. Well, are there any sharp corners or cusps? No. Any places the function's not continuous? No. Any places where the tangent line is vertical? Yeah. Where is that? We have a vertical tangent line right here, or close to vertical. It's a little hard to tell from the graph, but it is actually vertical. Not differentiable when x is equal to 0, because we have a vertical tangent line. And you could see this by taking the derivative, right? Y prime, because of the power rule, is bring down the exponent, subtract 1 from the exponent, and we could rewrite this as 1 over 3. I am going through this quickly on purpose. I just want to show you the answer. This is what the derivative looks like. When x is equal to 0, what's our derivative? When x is equal to 0, what's the slope? What's the derivative? It's undefined. When x is equal to 0, we're dividing by 0. That's a big problem. So you can see it graphically and analytically with functions, is what I mean by analytically. Two ways of seeing it. But all you need to answer this question is to look at the graph. Three ways: tangent line vertical, sharp corner or cusp, or functions not continuous. Let's look at this next one. Where is the absolute value function not differentiable? Any place with a vertical tangent line? No. Any sharp corners or cusps? Yep. Right here. It is not differentiable when x is 0. And this can kind of make some sense, because from the left, what's our slope over here? Our slope is -1. From the right, our slope is +1. Where they meet, well, it's kind of -1, but it's also kind of +1. It's a little bit of both. The derivative doesn't exist. It's different from one side compared to the other. That may remind you of limits. The derivative actually is a limit, and that's why. We have a slope from the left, we have a slope from the right. They're not the same. The derivative doesn't exist. What about over here? Let's throw a bunch of stuff together. We have any vertical tangent lines? Yes, we do. So, doesn't exist when x is 2. I put a comma because you can bet there's going to be more. Any other vertical tangent lines? I don't think so. What about cusps or corners? Got one right there. Yep. When x is equal to -1. What about discontinuities? Jumps in the graph. We have an infinite discontinuity here when x is equal to +1. It goes off to infinity. That's why it's an infinite discontinuity. We also have a discontinuity here. The function's not even defined here. But yeah, it's not continuous. So the derivative doesn't exist either. All right. I think those are all the places where we have no derivative. Let me know if you have any questions. But that's this video. Bye-bye. I really say bye-bye pretty much every video, don't I? Toodaloo.